Not if it says that to go on the spot. Just like his email.
All right, I think we'll go ahead and get going.
When you go to Explore.
My name is Frank River. I'm the moderator for the afternoon collections presentation here for the next couple sessions. I'd like to start out with a quick thank you to Beaver Equipment for sponsoring the group of collection system or collections sessions today. Also, just a reminder, if you have CEU sheets that you'd like stamped, go ahead and give them to Brian in the back, and he'll take care of that, have it ready when we're completed. So we'll move on to the manhole lining presentation here with Peter Ordonez, or Robin, excuse me. Too many names on here. Robin Ordonez. Robin's a civil engineer with a bachelor's degree in civil engineering from San Jose State University, and licensed in Oregon or Washington and Idaho. He's worked in consulting for 5 years. Prior to that, he was with Pierce County for 28 years, retiring as the assistant wastewater utility manager. He was responsible for the management of the capital improvement program, utility local improvement districts, comprehensive sewer plan, permitting and construction experience during his time at Pierce County. In addition, he was the project manager for Pierce County's Sound Grow fertilizer manufacturing facility, technology selection, design, and product marketing. He currently serves as technical resource engineering consultant for Credle Systems North America.
Thank you. Good afternoon. This presentation today is about a manhole or a sewer system in Oliver, British Columbia. So it's titled Concrete Manhole Barrels Disintegrate While Blind Manhole Bases Remain Unscathed. It was prepared for this conference by Peter Keith, who's the author, with contribution from myself and Ramon Estaro, we're from Cradle Systems, and Steve Underwood from True Consulting up in British Columbia. Oliver, British Columbia is a town of about 5,000 people, and it's located in the Okanagan River Valley, which is about 15 miles north of the state of Washington, the Washington state border. It's the northern limit of the Great Basin Desert and the only desert in Canada. And it's also the wine capital of Canada, and it's located on Lake Tuc-Inuit. In 1992, the town of Oliver extended its sewer system, and they extended a gravity system to take in some residential properties along Lake Tuc-Inuit. It's about 2,700 feet long, 17 manholes. And an interesting thing about this gravity line, it used to be these properties were provided with septic systems prior to that, and they were connected into the gravity system. The city acquired easements across all those lakefront properties and installed the sewer force or the sewer gravity line. Now, the interesting thing about this sewer system is that one of the things that the city or the town wanted to do was they wanted to connect another residential area with a pump station. It's the Stewart Road pump station on the very north end of the project. And so that force main took sewers from about 200 homes to the Stewart pump station through this gravity system and connected the 30 homes and to another pump station down to the south, which is the Rotary Beach pump station. So the red force mains were installed in 2002, and of course you can tell the names of the road names of the streets in this area are Pignot, Chardonnay, Shiraz, Gamay, and Cabernet. And so what do you think they do here in the town of Oliver? Immediately they had minor odor complaints. Odors were thought to result from low flows. When you consider you have a minimum grade 8-inch sewer line with 30 residents along the beach and about 200 residents. So the minimum grade, you could never attain self-cleansing velocity, so therefore they had sewer issues or odor issues. Oliver constructed sewer vents from the manholes up into the trees to dissipate the odors. So the vents, basically they reduce the detectable odors from the residents along the beach and quote unquote solve problems, not necessarily, as all of us in the sewer business know that you still have some issues. And so for the next decade, it was uneventful. In 2002, a winery was connected to the new sewer via force main that's shown in red. This sewer line is about 2.1 miles long, a force main, and it also connected into the end where the other force main from the into the Rotary Beach pump station or into the Stewart Road pump station. So a stench arose immediately. It was highly odorous. So the town decided to remove the extra vents from the trees, and so there was still no reduction in odor complaints. So they installed charcoal filters on the manholes, which proved to be ineffective and also required a lot of maintenance. So the town removed them. So Oliver's fight against odors continued. They installed P-traps on the sewer laterals, similar to the P-traps under your sinks, and they were somewhat effective, but odor complaints continued. Well, they obviously stopped the odors going from the gravity sewer system up through the individual residential vents, and that's what was occurring. So the town decided to encapsulate the manhole covers in plastic bags and buried them under 4 inches of soil. So basically, the odors were removed. Well, let's put it this way. They were removed from the senses of the residents, but they were trapped in that gravity sewer line. So something else was bottled up, obviously the hydrogen sulfide. So in 2007, part of the main interceptor near the wastewater treatment plant, Oliver's wastewater treatment plant, collapsed. It completely collapsed. And so Oliver quickly replaced the interceptor with a 36-inch PVC pipe. Concrete manholes were replaced with IPEX manhole structures. And by the way, this 36-inch line was 25 feet deep. And so the manhole barrels along Lake Ilnuit were discovered to be badly corroded. What they did was, once they had this collapse, they went and investigated all their collection system and found that the source really was in this gravity line. So when the winery waste the effluent was tested, it was found to be highly acidic and extremely high in BOD. With pH of 4 and BOD concentrations as high as 14,000 milligrams per liter without pretreatment. And of course, average residential wastewater is more neutral pH between 6 and 9, and a lower BOD of between 100 and 400 milligrams per liter. Also, some of the things that went unreported were some spills into the collection system, which ended up into the pump station that was directed to the gravity sewer. So they had a number of issues with unreported spills as well. And so obviously the winery waste was quite abnormal since it was not pre-treated. And so the town concluded that the winery was causing the corrosion. So the acidic winery waste had disintegrated concrete barrels in only 5 years. And to the point where the aggregate was exposed and also some of the rebar, and in some cases, actually soil was coming through on some of the corroded portions of the manholes. Fortunately, the fiberglass reinforced polymer lined manholes, the bases were completely intact and still flowing. And so this allowed the town of Oliver to replace the cones and covers on top of the existing bases while it was still operational. The new FRP line barrels were installed on the existing intact bases, and the shallow 8-inch Inuit sewer remained in service all the time during construction. And they reused the manhole bases and avoided bypass pumping, saving about $13,000 in bypass pumping costs. But actually, replacing those 17 manhole bases would have cost somewhere in the neighborhood of $250,000 more on this construction project. So in 2012, the winery, and I'm not sure they voluntarily added pretreatment, but they added pretreatment, and where the average BOD dropped from 4,000 milligrams per liter to less than 200 milligrams per liter. So the Oliver story ended well. The corroded manholes replaced with the corrosion-proof FRP line manholes. The yellow bases reduced construction costs, at least as far as the bypass pumping was concerned. And pretreatment greatly reduced the acidic concentrations in the collection system, and also they lowered the BOD. So Oliver has started to live happily ever after too. Maybe so, but the author of the report needed to know more. And so the question arose is, what about the long-term performance of fiberglass reinforced polymer liners? This looks like a promising technology, but how effective is it? What is the known service life? Do they really reduce maintenance? Are they truly corrosion-proof? For my favorite, do you have any before and after rehab data? For answers, we looked to the largest and oldest database of manhole liners in North America, and that's in Pierce County, Washington, the Pierce County Sewer Utility. It stretches from Puget Sound on the west and the city of Tacoma on the north to Mount Rainier on the east, and has an average annual precipitation of 39 inches up to 115 inches. Pierce County Sewer Systems is about 78 square miles in service area. They serve 250,000 people. I began installing the FRP manhole bases in 1989, which is about 25 years. And to date, 11,000 have been installed on their sewer system. The sewer system has about 18,000 manholes, and prior to that, the sewer system came on board in 1984. That's when the trip plant became operational. So for about 5 years, for the first 5 years, they installed about 6,000 to 7,000 manholes. Their collection system is about 870 miles of sewer mains, anywhere from 8-inch to 84-inch in diameter. About 700 miles are public sewers, and 170 miles are private sewers. Pierce County, in their infinite wisdom, decided they didn't want to take over the maintenance of private sewers, and so the ones that were installed in private roads and private property were owned and operated by the property owners. But the standards for the sewer collection system are the same, whether it's public or private sewers. So did the liners really reduce maintenance costs? Well, The early flows in the treatment system, or in the collection system, was about 5 MGD. The plant was designed for 12 MGD. So a lot of the sewers were designed for the overall basin, so the slopes of the gravity lines were based on full buildup. So the early flows were too low to pass the solids through the concrete channels. And the county began to notice that there were some corrosion issues in the channels. And to eliminate the corrosion, the county rechanneled dozens of manholes where they cleaned and plugged and jackhammered and recleaned and reformed the concrete troughs. And typically 3 to 6 people were needed during this operation, usually about an entire day for a manhole. Rechanneling costs 4 workers and 2 trucks, 4 workers at $20 an hour, 8 hours a day, and overhead factor of 3.0. Vector trucks at $3,000 a day, and a cleaning truck, flush truck for $1,600 a day, about $6,500 a day. Didn't always necessarily stop the clogging in the troughs. So the county discovered the FRP baseliners in 1998. A salesman stopped and talked to the engineering manager, and a couple of weeks later, in a conference meeting, the manager, the engineering manager, and the maintenance manager were discussing where his staff was going with maintenance folks, and he talked about that they had to go back out and they had to rechannel a bunch of manholes. And so the engineering manager spoke to the maintenance manager and asked him to take a look at these FRP liners. Consequently, in about 1989, the first project was put out where these liners were sole sourced, and to this day they're still sole sourced on the Pierce County sewer system. So basically, improving the vision. It's nice bright yellow. It's easy to see when you pop the lid. They don't clog. The managed roughness coefficient goes from 0.24 to 0.10 because it's fiberglass reinforced polymer. And a typical cost on a 48-inch manhole for one of these liners is anywhere from $500 to $900, depending on the number of channels that you specify. And so never having to clean or rechannel another manhole is nearly priceless. So how reliable are the liners? There have been 6 liner breaks in 25 years in 11,000 manholes. 4 were caused by improper repairs where a developer cut into an existing manhole and their contractor repaired the existing liners. And 2 of the defects we're not sure how they were caused. Some of the things that have happened in the past is when workers are working on the system, they'll drop tools and possibly break the liner, and they have to be repaired. So all defects can be repaired in place, and 99.95% were intact through construction. So how effective are these liners against corrosion? Lab testing results on a 20-year-old specimen, which was removed in 2013 and tested by Polymer Engineering Company of BC. They used energy dispersive X-ray spectroscopy, Fourier transmission or transform infrared spectroscopy, scanning electron microscope, and mechanical destruction. And the conclusion of this testing company was that the liner was completely intact, there was no sulfur intrusion into the concrete, and that the concrete was actually stronger. So how waterproof are the liners? All FRP sections are heat welded in the field. All connecting pipes are gasketed at the a choice of 6 different types of gasket, whichever are specified by the owner